Hello, so let's try this again. So we would like to map out one pin, be able to map it out to the actual memory address on the BeagleBone Black. So let's see, for example, you have a project that you want to write and you want to use, I believe this is P9. You want to use one of these pin and you don't know what to use, and you decide, hey, let me pick example P9, which is this header area, um, number 12, which is somewhere here, number 12. So you want to go here, go to the pinout for the pin header 9. I believe this is 9. So expansion header pin 9 or P9, and let's say we want to do the 12th pin. So by default it's set up as a GPIO 1_28, and if that means that it is set up as mode 7 GPIO 128. Now you have this information. Now you want to be able to map it to the memory address on the BBB. So let's see how we can go ahead and go about that. So what I would do first is to get the GPIO information, GPIO info, and what that gives me is all the pin numbers and the name description, and if it's input or output state, current state right now. So for our P9_12, we can look for it here, P9_12 right here. So we can see that it's actually in the 28 that it mentioned, and currently it is in output. So it has some voltage in it. If we measure it on the DMM, it should have some voltage in it, and this is actually in the group 0. Notice there's some discrepancy here. It actually said I should be in group 1, but it's actually in group 0. So I will go with this. So we are looking at P9 12 group 0_28. So that's essentially where we are now. Now that we know this information, we have this information, we can even go further by looking up the device tree kernel. So if we do a list, all right, so if we look up what is in here, you could see that we have our pin mux pins, and we also have our pin. So in order for us to see what is in our kernel, we can go ahead and open that pins up. So when we open it up, we can see our current address, or this is our register address here. So now remember, our pin, a P9_12 is in bank 0 28. So P9_12 12 by 0.28. So let's do some calculation here. So that will be 0 times 32 bits, then plus 28. So that will pretty much be equals to GPIO underscore 28, right? So if we use that, we can look at our pin address and we can look for 28 here, pin 28, 28. So that would be this address. So now we want to copy this. Okay. So this is the address that so our address leaves our pin. Let me go here. P9 underscore 12 currently lives in this address, and our offset here or current holding is 37, which is essentially the binary version of 37 is here's a way to calculator. Programmer, and we can do hex 37, or yeah, 37. So that's the binary value of where we are. And based on this address, we can say that the bit, the lower bit, is mode 7, which is GPIO. Then our bit 0, bit 3 is pulled enabled. If we go back to our, oh, I still have this here. So this is mode 111, which is mode 7, and our third bit here is actually 0, which is pull up or pull down enabled. Let's go back. Let's do this side by side and do this here. I guess I need that. So that's 0, and this next one is a pull up is 1, and also input buffer enabled is 1. So let's go here. So that's pull up is pull up resistor, and this is also 1, which is enabled, receive enabled, which is also 1. So basically an input GPIO value. So what this is telling us is that this particular pin is a GPIO. Setup currently is GPIO with internal pull up and the input and we can verify, we can run this command here to see remember it's bank 0 AM3358, and we can see that it's currently active, so it's high and outputting voltage. So that's one way to basically, be able to map out your pin from the header all the way to the module register address. So I hope that was slightly helpful. I was trying to get some clarification on this. So there's some important things here. This is usually known because you have access to the 8 on the board. The address here is usually unknown or tough to find. So this is where you use the command to basically find out a little bit of investigation to find out what address it is currently in the device tree. Then based on that, you can use this value to decode the current state of this particular address. Right now everything else is 0, and we have this setup, which is basically setting up our meter mode, pull-up resistor, rxactive, setting those up. So right now it's set up as GPIO internal pull-up, and it's an input state. So, and you could do the same thing for the other headers and kind of track it down like this, and you could use this to build some kind of memory map. Add this value, and you can even write out this default state that your pins are whenever you boot it up. So this will be the default state for this particular board using the current device tree binary running the board right now. So let me stop right there, and I hope this was a little helpful. Thank you. Bye bye.